Accelerated Algebra 2 stirrup here. So we have notes for 4E, solve an opposite inequalities, visual approach to the number line process. So if we take a look at this first example that's up here, we would have had these two equations that were graphed. And take a look that there are two x values that work, so -5 and also -1. Those both work. Those are the solutions to the problem. But if you scroll down the screen and you take a look at the second problem, notice that this equation here and this equation here, they don't intersect, so there is no real solution, no NRS, no real solution for this problem because the graphs themselves do not intersect each other. But we're going to go along a little bit more with this and think about what this would look like. Let's go to our second page. So we're going to go ahead and graph both of these. Okay, we're going to graph them both independent of each other. So I'm going to graph this side first. So basically that looks like -3, which is here. This is our turning point. And so this graph looks like this. And then we want to say, hey, where is it greater than 2? Well, think about this as y is equal to 2 or f at x is equal to 2. So that's a horizontal line going through 2. So count up, and this is coming straight across this way. Okay, so these points here are vital for us. So we want to know where is our original graph this blue one, where is this one? Where is that greater than this? And it's greater than it right here. I'm going to make that an open dot because it's a greater sign. And it's greater than it here. So what we're going to do is we have to identify where is this region and where is this region? Where does that take place? And those brackets are just there to talk about the graph. So if I come from over here, I'm coming from -infinity. From -infinity all the way up to 1, 2, 3, 4, 5. That's -5. Rounded bracket. Our graph is greater than or a larger number than. And then from here, so that's at -1, and that continues forever to infinity, So this is our solution to this problem. Where is that solution? So from -5 or from -infinity to -5, rounded bracket because we don't have the equal sign there at all. And from -1 to 8. So you're talking about in the x direction, where is it greater than that graph? Okay, let's try. So now we're going to take a look at this with the number line. Okay, and we're going to make the zero maker, and we're going to call the zero maker the critical value. And so if you see me put CV, that's the critical value. Okay, so set up the two possibilities for this equation. So we're going to do this without graphing it. But we're going to think about it on a number line where this is going to take place. So my critical value is set that equal to 0. So x equals -3. So -3 is my critical value. So I'm going to put a point at -3. And that's my critical value, CV. Okay? And then we want to know where our graph itself was greater than 2. So take a look. If I solve this, I have x plus 3 is greater than 2. So that gives me subtract 3 from both sides, -1. And then I'm going to go x plus 3, and I'm going to flip the sign, is -2. So then I'm going to go ahead and subtract the 3 from both sides, so I get -5. So that's where our information is correct, and things that we might want to think about. So let's flip this one over because it's smaller. It's more to the left. So I get -5 is greater than x. So then I can put this back together with this. So it's -5 is greater than x, which is greater than -1, or so from -infinity to -5, and from -1 to infinity is how we would write it as interval notation. Interval notation. Okay? So you're talking about regions that work. You know, this right now, this didn't really help us a whole lot with our line, but basically we could say, oh, well, I have -5 here, I have -1 here. So this is the region that we're talking about, and this is the region we're talking about. And we have open dots there because we don't have the equal sign with that. Okay, so all of that kind of goes along with the same, excuse me, same answer, but we're looking more for the interval notation. So it's easy to look at this for an interval notation, read it left to right, and just go from there. If you have any questions about this, happy to talk about it more in class. So let's talk about this first problem. So let's just draw ourselves a line. Let's find my critical value. So I have this. So 5 is equal to x. I add an x to both sides. So I have a 5 there, so that's my critical value. And let's go ahead and solve this two ways. So I'm going to drop my parentheses, or absolute value signs, and then solve that. So I'm going to get negative x is less than, subtract 5, so I get 2. So x is greater than -2. And then the second one, we're going to subtract 5 from both sides. And then I'm going to divide each side by -1, make sure those signs flip over. So if I have a critical value down here at -2, I also have our critical value of 5, I have that -2, and I also have that 12. So the distance from -2 to 5 is the same distance as it is from 5 to 12. Okay, so now I wanted values that were less than 7. Okay, less than 7. So let's think about this. So my feasible region, I want values that are going in here and are going in here. So these are open dots because I don't have an equal sign. So that is where my answer is as on a number line. So if I write it as an interval notation, I'm going to go from -2 to 12, rounded brackets on both because I have open dots. That is not a point. That is the region that would allow us to have values. If I plugged any numbers from -2 to 12 in for x, my answer would have a result that is less than 7. So, pick a number like 0. 0 is in between there. 5 minus 0 is 5. Absolute value of 5. 5 is less than 7. Totally works. So this is our interval notation. That's the answer we're looking for. And again, we can talk about it in class if you'd like. Okay, let's be careful with these. So now we have the equal sign there, which is fine. So my critical value here is, I'm going to go 3x minus 1 is equal to 0. 3x is equal to 1, so x equals 1/3. If I did this on a number line, I'd have 1/3 right here, somewhere on the number line, somewhere in the middle. And if I would go ahead and solve this, this is what's kind of weird. So I have 3x minus 1 is less than or equal to 0, and then I also solve for 3x is minus 1 is greater than or equal to -0. Well, -0 and +0 is the same thing. So here I'm going to get x is less than 1/3 if I solve it, same as my critical value. This will be x is, by add 1 divided by 3, x is greater than or equal to 1/3 as well. Okay, so what does that mean? So this is my critical value, but if I graph this, I'm going this way forever, including the dot. And if I graph this, I'm going this way forever, and including the dot. So on this one, it looks like everything's going to work. So I go from -infinity to +infinity, and that's my solution to this answer. If I plug anything in, I get something less than 0, less than or equal to 0. So, but let's talk, friends. Let's pick 5 and plug it in. 3 times 5 is 15. 15 minus 1 is 14. Absolute value of 14 is 14. Is 14 less than 0? No. Let's pick another point. Let's pick, like, I don't know, 100. So I get 300 minus 1, which is 299. Absolute value of 299. Is 299 less than or equal to 100? No. So this really isn't working. So this has no real solution for our answer. So that's kind of a trick on it. So you have to kind of think about, oh, like, I got this to work out really nicely, but then plug some values in, and if things don't work, then we have to take a look at it. So let's take a look at this second problem. This is done the exact same way. Notice my sign has flipped. So my critical value is still here. So I have an open dot because I don't include it. And if I had done the same graph and plugged in values on this, So if I plug 5 in, I get 15 minus 1, which is 14. Absolute value of 14 is 14. Is 14 greater than 0? Yes. So it's happening over there. It's true. If I pick some value to the left of it, I don't know, pick negative 10. 3 times negative 10 is negative 30. Negative 30 minus 1 is negative 31. Absolute value of negative 31 is 31. And that's also true. So all my points will work except for my critical value. So my interval notation is negative infinity to 1/3, rounded bracket, 1/3 to infinity. So that's my answer, the blue, the negative infinity to 1/3 and 1/3. And I have rounded brackets at the 1/3, so that means I don't include that point. This next problem is done the exact same way, but we want to know where it's equal to. So again, I have that 1/3 as my critical value because I solved that equal to 0. So I want to know exactly where it's equal. And I can't plug values in other than 1/3. If I plug 1/3 in, I get 0. I get absolute value of 0, which is 0. So this is my only solution. So in this case, we're going to say that x is equal to 1/3. So we actually get a number, a numeric value here, and that's my answer there. And then the last problem, we changed the very last value to negative 4. Okay, now, I want you to think about this, my friends. This is just logical thinking. I'm not even going to graph it. If I take the absolute value of something, I get positive out. Absolute value is distance away from 0. So no matter what number I plug into that x, I'm going to get a value that happens to be greater than, it'll always be positive. It'll either be 0 or bigger than that. So can this happen? Can this happen? And this can't. It can't, because no matter what number I plug in for this x here, I'm going to get a positive answer. So where would I have values that are less than negative 4? I don't. So this has a no real solution for our answer. Little trick on that one. Okay, questions you have in class, please bring them to me. Make sure you have all the notes you need. Have a great day, everyone. Take care of one another.